Okay, so next we're going to talk about internal relay instructions. What is internal versus external? What does that mean to us? When we think of internal relays, I want you guys to think of as internal instructions as being binary, integer, double integer, counters, timers, anything that's internal to just the PLC, something you wouldn't see external to it. When you think external, I want you to think inputs and outputs. That's it. That's all the external associated. Anything that is required, either input coming in or output going to a device, that's considered external devices. Everything else is considered internal. So internal relays, again, just like everything else we've been dealing with, is OTEs, XICs, XIOs. Okay. Again, internal relays, we use them very extensively in this class. I try to get the class to understand some of the new concepts of, well, not really new concepts, like the concepts of writing good programming, good programming, or how about this, the understanding of developing good programming techniques and skills. So we're going to be using a lot of internal relays. Internals to develop code. Good programming practices typically don't utilize the outputs as part of the code, as part of the logic to develop the operations. It's the result of all the code is written is what the outputs are driving. So as you can see here, again, they're using some sort of internal relay to turn on an output, and that's very common. This is something that you guys will be getting very accustomed to as we continue on in this class. And here we're showing how an internal relay, like a B bit or something of that nature, would click on and off, allowing us to control a real-world output. So here they're showing us a hardware circuit again. I'm going to kind of flip through this a little bit quickly because this is a little silly. I mean, we understand that that this is a PLC program and this is a hardware circuit. And here's an opportunity to see how all that ties together. So sealing circuits done here at the top using internal relays. After that is turning on a series of outputs. Latch unlatch instructions. The only thing I have to say about those is we are not using them. Any program that I've ever come across that a machine builder or other programs have told me that there's no other way to do it except with a latch or unlatch, I have proven them wrong. So unless you can prove to me that that was the only way to program some aspect that you're trying to accomplish, I am not going to accept it. So keep that in mind. The latch and unlatch is definitely a piece of the Allen Bradley puzzle, but not one that we're going to be using. So kind of, if you would, scratch that off the list of tools that are available to us in the Allen Bradley software. That's pretty much one of the very few tools that I say we're not going to use, only because it creates more confusion than it's worth, and troubleshooting is a real pain in the neck, so keep that in mind. So I'm going to zip right through this. One-shot instruction. Yes, we like one-shot instructions, so we will be using those. We'll like them a lot. Because, why? They give us one trigger of an to start a process, and I like that. Why do I like that? So when I tell a process to start, I'm giving it one trigger. I give it one really short trigger, one very short trigger to start. When I'm developing my code, I want to know when I started it and when I stop it. If I start, stays on the whole time, comes on and stays on the whole time, there's a possibility that my system may see that start signal still on when it gets done and want to start again. I don't want that to happen. I want it to start when I tell it to start. Right there at that very peak of that start. That's when I want to start. That's the only time I want to start. And when it sees my signal go from an off state to an on state back to an off state. It's the only time I want that to start. So even if someone comes along and holds that start button down the whole time waiting for that next cycle to take place, it's not going to happen. Not till they release it and they press it again. I just do not want that to take place more than, or except when I tell it to. So all my processes start with a one shot. So we're gonna be getting further and further into that as we continue in class. But I want you guys to really grasp the one shot. I think you'll once you figure out how to implement that into your code, you will find it to be a very handy tool to have in your toolbox to get you through some really basic operations and make things happen for you. So here they're kind of giving us an illustration of the one shot. The one point that I want to make is that there's a ONS here, there's also a one shot falling, and then there's a one shot rising, OSR or something. And we'll be getting into those in the lab a little bit, fooling around with those. But here what they're illustrating is they put the one shot in front of the add statement, and command, excuse me. With that one shot in there, these add only takes place every time that goes from an off to an on, okay? It's not happening continuous. Otherwise that add would be continuously added. Every scan, that thing would be adding another contact, another one to that source A, incrementing that on a very rapid rate. So by putting one shot in there, it only adds it once every time you hit the button from an off to an on state. The one shot rising, here's that command I was talking about a little bit earlier. You'll see it's got 3 bits to it. One shot rising, or excuse me, 2 bits. The storage bit and the output bit. What it's looking for is 2 bits. Storage bit, of course, and then the output bit, of course, yeah. The storage bit is the way the input works, or the block works, excuse me, is that it's looking for, you'll see here, a transfer from a 1 or 0 to a 1. When it sees that take place, it holds that information until it sees that input to that block go from a 1 back to a 0. And once that's taken place, it'll accept the next change of state. So utilized pretty regularly throughout the program. So you'll see a lot of this. One shot falling, instead of going from a positive to a negative, it's going from from on to an off. It's going from off to an on, to an off to an on. So it's just reverse. Here is kind of an example, a program of it, and then they went ahead and put it into play here. So you can see how that one shot rising works and the one shot falling. Noticing the addressing that's being utilized here. You know, you got that bit there being used here, and you got the OSF bit being used here. So that's how that's all tied together. So that is the end of today's slideshow. We're going to pick up with the next slide. Will be chapter 15, part 3, and so we'll be talking to you guys soon. Talk to you later. Bye.